The Virgo cluster is a cluster of galaxies whose center is 53.8 plus or minus 0.3 mly away in the constellation Virgo, comprising approximately 1,300 member galaxies. The cluster forms the heart of the larger Virgo Supercluster, of which the local group is an outlying member. However, the LG experiences the mass of the VC Supercluster as the Virgocentric flow. It is estimated that the VC's mass is 1.2 times 10^15 m out to 8 degrees of the cluster's center, or a radius of about 2.2 mpc. Many of the brighter galaxies in this cluster, including the giant elliptical galaxy Messier 87, were discovered in the late 1770s and early 1780s and subsequently included in Charles Messier's catalogue of non-cometary fuzzy objects. Described by Messier as nebulae without stars, their true nature was not recognized until the 1920s. The cluster subtends a maximum arc of approximately 8 degrees centered in the constellation Virgo. Many of the member galaxies of the cluster are visible with a small telescope. Its brightest member is the elliptical galaxy Messier 49. However, its most famous member is the also elliptical galaxy Messier 87, that, unlike the former, is located in the center of the cluster. Characteristics: the cluster is a fairly heterogeneous mixture of spirals and ellipticals. As of 2004, it is believed that the spirals of the cluster are distributed in an oblong prolate filament, approximately 4 times as long as it is wide, stretching along the line of sight from the Milky Way. The elliptical galaxies are more centrally concentrated than the spiral galaxies. The cluster is an aggregate of at least 3 separate subclumps. Virgo.It centered on M87, have second centered on the galaxy M86, and Virgo.B that surrounds M49, with some authors including a Virgo C subcluster centered on the galaxy M60, as well as a LVC subclump centered on the large spiral galaxy NGC 4216. Of all of them, Virgo.It, formed by a mixture of elliptical, lenticular, and usually gas or spiral galaxies, is the dominant one, with a mass of approximately 10^14 m, which is approximately an order of magnitude larger than the other 2 subclumps. The 3 subgroups are in the process of merging to form a larger single cluster and are surrounded by other smaller galaxy clouds, mostly composed of spiral galaxies known as N cloud, S cloud, and Virgo.E that are in the process of infalling to merge with them, plus other farther isolated galaxies and galaxy groups that are also attracted by the gravity of Virgo to merge with it in the future. This strongly suggests the Virgo cluster is a dynamically young cluster that is still forming. Other 2 nearby aggregations known as M cloud, W cloud, and W cloud seem to be background systems independent of the main cluster. The large mass of the cluster is indicated by the high peculiar velocities of many of its galaxies, sometimes as high as 1,600 kilometers per second with respect to the cluster's center. The Virgo cluster lies within the Virgo Supercluster, and its gravitational effect slows down the nearby galaxies. The large mass of the cluster has the effect of slowing down the recession of the local group from the cluster by approximately 10%. Intracluster medium. As with many other rich galaxy clusters, Virgo's intracluster medium is filled with a hot, rarefied plasma at temperatures of 30 million Kelvin that emits X-rays. Within the intracluster medium are found a large number of intergalactic stars, including some planetary nebulae, that it is theorized were expelled from the home galaxies on interactions with other galaxies, as well as some globular clusters, possibly stripped-off dwarf galaxies, and even at least one star formation region. Bright and notable galaxies of the Virgo cluster. Below is given a table of bright and notable objects in the Virgo cluster and the cluster's subunit where they're located. Note that in some cases a galaxy may be considered in one subunit or in another. Column 1. The name of the galaxy. Column 2. The right ascension for epoch 2000. Column 3. The declination for epoch 2000. Column 4. The blue apparent magnitude of the galaxy. Column 5. The galaxy type. E equals elliptical, S0 equals lenticular, SR, SB, SC, SD equals spiral, SBA, SBB, SBC, SBD equals barred spiral, EDM, SBM, IRR equals irregular. Column 6. The angular diameter of the galaxy. Column 7. The diameter of the galaxy. Column 8. The recessional velocity of the galaxy relative to the cosmic microwave background. Column 9. Subcluster where the galaxy is located.